So Kipsters will be able to use dimensional analysis to write slope-intercept equations from real-world problems. So what does this look like? Well, this looks a lot like what we did on Thursday, except on Thursday when we wrote slope-intercept equations, the problems that we had didn't have any y-intercepts. The problems that we're going to have today are going to have y-intercepts. And if we think about what a y-intercept is, it's realistically just our starting point. Okay, it's where it is on that y-axis when we have no x, when x is equal to 0. Okay, so we're going to look through this problem and we're going to start setting it up almost exactly the way we did before. It says the cost of an ice cream sundae depends on the number of scoops of ice cream you add. The sundae costs $3 plus an additional $1.50 per scoop. Write an equation to represent the cost and the number of scoops. So we should be looking at our relationship is going to be something between the cost and the scoops. So we should be looking for our rate already. Where's our rate? Between cost and scoops. $1.50. Does that give me a relationship between cost and scoops? No, so that's not a rate. James. Yeah, one scoop. $1.50 per one scoop. Or we could say one scoop is $1.50. So down here, we're trying to figure out how much it's going to cost. And here, this is as much information as we were given in our previous problems from Thursday, where we would write, all right, so we're trying to find out y dollars. Which of these two rates do I need to use to find out y dollars? Number 1 or number 2? Looking at my work, which one do I need to find out y dollars? Number 1 or number 2? So I'm going to use the first one because that's going to match up my units, my dollars on top. $1.50 for one scoop. Strictly thinking about the units. What are the units of my situation going to be if this is going to cancel out right? What are the units of my situation going to be if the units are going to cancel out right? What do I need to be able to plug in here if my units are going to cancel out right? Don't look at the word problem. Look at the units in our dimensional analysis. What units do I need for this to cancel out right? Blanca. Scoops. I need to know how many scoops. Does it tell me how many scoops? No, and that makes sense because in this particular problem, they're just asking us to write an equation. X scoops. That makes our scoops and our scoops cancel out. That just leaves us with our dollars and our dollars. Now, whenever we do this and we leave our equation like this, that suggests that our equation starts at 0, 0. In other words, at this point, I would suggest that the starting price of the sundae is $0. Is that true in this problem? No, what is the starting price? What is that y-intercept? Isais? $3. Now, one thing to notice about this $3 is that the units are dollars. I'm adding $3 for the initial price. All of our units that are left, dollars is equal to dollars plus dollars. That makes sense. You can't have dollars equal to dollars plus scoops. Right, that doesn't make any sense. So our starting point over here we said was $3. Now that we're ready to write this as a single equation, I bring down my y. I just take off its units because I don't need the units when I'm writing the equation. 1.5 over 1, well, that's just 1.5. Times x scoops, so times x, 1.5x plus 3. This is the equation that represents the situation, where y is the amount of money that it costs, and x is the number of scoops. Next problem. A spring is 3 inches long and stretches 2.5 inches per kilogram of weight that is added to it. Write an equation for the length of the spring in relationship to the amount of weight that is added. So we're looking to find the length of the spring. What is the units for length of the spring? What are the units for the length of the spring? So what I really like about that is that it also helps us recognize that our starting point and the answer for our units should always be exactly the same. Otherwise, we end up with that weird situation where we end up with dollars is equal to dollars plus scoops. All right. So our starting point, or our y-intercept, should always have the same units as our answer. So what is our given rate in this problem? What is our given rate in this problem? James. All right, 2.5 inches per 1 kilogram. Or we can write that the other way. So as we get ready to come over here and start setting this up, I have y inches. Which rate do I need, the first or the second? Which rate do I need, the first or the second? So I definitely need the one with inches on top, so that's the first one. But I need a situation to cancel out those kilograms. So what are the units of my situation? Jari?
X kilograms.
Yep, x kilograms. It doesn't tell me how many kilograms. We're just setting up an equation. We want to check our units at this point. So far it's inches and inches. So if I'm going to add a starting point, that starting point better be in inches. What did we say our starting point was?
Inches.
3 inches. Inches equals inches plus inches. That makes sense. So when we write our equation, we have y is equal to 2.5 over 1 is just 2.5. X plus 3. All right, so these are two easy ones. The next one's going to get a little bit more complicated because it's going to start involving some things that we've learned in 7th grade or dealt with a lot more in 7th grade in terms of negative numbers. Zeke owes the bank $300. If Zeke works a job that pays $10 per hour, write a relationship to relate Zeke's total net worth with the number of hours he works. All right, so we're trying to find out his total net worth. What are the units for net worth? How much are you worth? Glad to see Najari is carrying a lot of weight today. It'd really be nice if somebody else pitched in. All right, so what is our rate? Yoel, what's our rate? $10 per hour. If you knew the answer, why didn't you raise your hand? Nor do I. All right, so I need my answer to be y dollars. And to match up those, I'm going to need this first rate, $10 for 1 hour. Which means my situation should be what? James. Situation. We moved on from our rate. So what do I need? What do I need my situation's units to be? If the units are going to cancel out right. Yeah, X hours. So our situation is X hours. And the question is there a starting point here? Is he starting right now at $0? There are 3 people answering this question. Is he starting right now at $0? No, so what's the starting point? Say Lolly.
-300 because it's a debit.
Yeah, negative 300s because it's a debt. He owes the bank $300. Negative $300. Now again, checking on our units here. Dollars. We got dollars left over plus dollars. Dollars equals dollars plus dollars. That makes sense. Starting point was negative $300. So write the equation without the units now. Y is equal to 10x plus negative 300.
Wait, so I'm going to
What's up?
that the equation would equal the number sentence, or it would be like that after the number sentence, except for the sentence.
All right. Lupita has sent 200 text messages already this month. If she sends about 25 text messages per day, write the relationship between the number of days and her total texts for the month. All right, so we're going to be thinking about how many texts. What's the rate? Sophia? Yep, 25 texts per day, so let's go ahead and write that down. So as I start to set this up, it's going to be y texts is equal to 25 texts per day. Times, what's my situation going to be? Blanca? X days. And then the question comes, do I have a starting point? Is she currently starting at 0 text messages? No, so what's our starting point? Angelina, what's our starting point? Yep, 200 texts. I really like that she threw the units in there because that helps us check. As I come through, days cancels out with days, but then I have this all looking across. Texts equals texts plus texts. So yes, this is good. Let's go ahead and write it out. Y is equal to 25 times x plus 200. We are going to do one more. This is going to be the trickiest one that we see. Let's not get caught here. All right, looking at this one, it says Kaylee had $125 of iTunes money. If each song costs $1.99, write an equation to represent the relationship between the amount of money Kaylee has and the number of songs she purchases. So the amount of money that she has, how much money does she start with? So what's our starting point? That's the easiest one for me here. Karen, what's the starting point? Yeah, $125. And so that also tells me that I know that my answer is supposed to be how many dollars she has left. What's the rate here? Najari.
I think it's $1.99 over.
What does $1.99 get you?
The song.
Yeah, one song. Now, this is where we actually have to be very careful and start to think about these rates a little bit more carefully. Is this $1.99 increasing the amount of money she has or decreasing the amount of money she has? It's decreasing. So what does that mean I need to do to my rate to make it work? If it's a decreasing rate, make it negative. So I'm going to put a negative out in front of these two rates because I know whichever one I'm going to use, it better be negative because this is decreasing the amount of money that I have. Y dollars is equal to, so I'm going to choose this one, so that's going to give me negative $1.99 for one song times X songs plus, what's our starting point? How much money do we start with here? Samaya? Yeah, 125. So our situation here was X songs. We get Y is equal to negative 1.99X plus 125. So Lally, question. We should remember that the units should help set up. The multiplication. Number 2. Units of answer. Should match. The starting point. And 3, a decreasing slope or a decreasing rate should give you a negative slope. So if your rate is decreasing the amount of your starting point, then you should be with a negative slope. Questions?